Okay, this video is on the difference between synthetic division and long division, and when you can use which are your options depending on what type of problem you have. So here we've got a polynomial divided by, notice what we're dividing by is in the form x minus a. Okay, so if you're dividing by a factor of it's x plus 2, x minus 7, if it's in the form x minus a, you can use synthetic division, which is a shortcut. Otherwise, you have to use long division. I'm going to show you long division first. When you're dividing by something besides that's not in the form x minus a, like let's say you have x squared minus 2 or something else, you have to use long division. So let's quickly review long division with numbers. So if you're dividing 10 divided by 4, when you set this up for long division, when you learned back in the day, 4 goes into 10 twice. 2 times 4 is 8, and then we subtract it, right? So the decimal's here. Now we don't usually write the decimal, but that's the end of the number, right? Okay, and then we go into parts of numbers. So when we subtract 10 minus 8, if 4 went into that number evenly, like let's say 8, okay, we know it went in evenly, we would end up, when we subtract, we would get a 0, right? In this case, we don't. We see we have 2 left over. Now, if we continue out dividing, we bring this 0 down. 4 goes into 25 times. So this decimal is here, so the decimal would be here, and we know it's 2.5. Okay. However, if we're going to write that fraction, if we're going to write that 0.5 in terms of a fraction, okay, once you get to here with long division, it's the same thing as if you have 2 over your original divisor, which is 4. So that's 2 2/4. So whatever you have left over, it's going to go over this number right here. Okay? So, and it's the same thing as if you were writing it as a decimal. We can't do the decimal because we're dealing with variables and not numbers. Okay, so we're going to go ahead and set this problem up just like we would do with regular numbers with long division. So this is like your 10 divided by your 4, right? So here's your 10 being divided by your 4. So let's see. So we need to think, what number can I put up here, multiply by x, that will give me x cubed? We know that's going to be x squared. Now I'm going to go ahead and put my x squared above the x squared here, right up here. Because that way, well, I'll show you when we get to the end. So if I do x squared times x, I get x cubed, okay? So that's x squared times x is x cubed. Perfect, because those are going to subtract and those are going to go away, cancel. And then I have to multiply x squared times this negative 1. I can't forget to multiply by the negative 1. X squared times negative 1 gives me negative x squared. Now, back when we were dividing, remember we have to subtract this whole thing. So you have two options. You can either, my dogs are growling, put your subtraction sign in front of parentheses and remember to distribute it, or you can just change the signs right away. Okay, make this a subtraction and make yours, when you're subtracting a negative, that makes it a plus. So these end up canceling, and this becomes negative 4x squared. And then I'm going to go ahead and bring down the next number, which in this case is negative x. Now we're just going to repeat. How many times, or what number, hold on just a second, my dogs are growling. All right, what number times x is going to give me negative 4x squared? So that is going to be negative 4x, right? So negative 4x. Negative 4x times x gives me negative 4x squared. Perfect. Those are going to cancel. Well, I can't forget to multiply my negative 4x by my negative 1. Negative 4x times negative 1 is going to give me a positive 4x. Now I'm going to subtract these. Okay, so this becomes positive, this becomes subtraction. So those will end up canceling, and I end up with negative 5x. And then I bring down my 5. Almost done. So we've got, this is a negative 5, right? Negative 5 times x gives us negative 5x. Negative 5 times negative 1 gives us a plus 5. That works out perfectly because when I subtract them, if I subtract this whole thing, these are going to cancel. These are going to cancel. I'm going to end up with 0. So what this means is that x minus 1 times x squared minus 4x, minus 5 equals x cubed minus 5x squared minus x plus 5. That's all that means. We just divided. So if we were doing this with numbers, right? 4 goes into 8 2 times. 2 times 4 is 8. That's all we're doing. Now, if it doesn't go in evenly, you would take the remainder, what's left over, and you would put it over. In this case, it would be 0, right? But it's usually some other number, over x minus 1. Okay? So let's go now to the shortcut. In this problem, we can actually use synthetic division. So I'm going to put the coefficients of my x cubed, my x squared, my x, and my 5 here. And I'm going to draw my division sign, but it's going to kind of be, let me just draw that a little lower, upside down. Okay, and we're going to be dividing now by the 0. In this case, the 0 is, that we're dividing by, is 1. Okay, so the 0, when I mean that, like the x-intercept, the 0, or you can think about it as a, you're dividing by a. So in this case, it's 1, not negative 1. So now, okay, so you start by bringing down your 1. 1 times 1 is 1, and you put it here. Now you're adding negative 5 plus 1, negative 4. 1 times negative 4 is negative 4. Now you're adding negative 1 plus negative 4 is negative 5. Multiply. 1 times negative 5 is negative 5, and this is going to cancel, and this is going to go in evenly, so that means that this x minus 1 goes into this polynomial evenly because we end up with a remainder of 0. This 1 now doesn't represent the leading coefficient for x squared because we've divided now 1x out of it. So that's now, or sorry, the original one was x cubed, right? Let me look here. Original leading was x cubed. So the degree is 3. So now this one is 1x squared minus 4 times x minus 5. That's what those numbers represent, the coefficients. And again, we've divided 1x out. So originally we started with an x cubed. We've divided an x out. That becomes an x squared. We had an x squared. We divided an x out. That becomes an x. And I think that's all I have to say. Yes. So you'll see we got the same answer. Long division takes a lot more effort and a lot more time and a lot more possibilities to make mistakes. So the more work you have to do, the more likely it is that you'll make a mistake. So don't use long division unless you absolutely have to. If you're dividing by x squared plus 2, you don't have a choice. You can't use the shortcut synthetic division. You have to do long division. So there it is. All right, peace out.